Z1, Z2, Z3 are distinct non-zero complex number such that this is the given condition. A, B, C, D is a set of real numbers. Show that this expression is equals to 0. Now when you have three expressions equals to each other, it will be much easier if we equate them to a constant, let's say k. Okay? Now look at this expression over here. You have a squared, b squared, and c squared. Let's rewrite this part as a over modulus of z1 minus z2 is equals to k. Then let's square it since we have a square here. So here will be a square over modulus of z1 minus z2 square is equals to k. Now, what is modulus of z1 minus z2 square? You learned earlier that now, if modulus of z square can be expressed as z1 multiplied by the conjugate of z1. So likewise, this expression over here can be written as a square over z1 minus z2 into, now conjugate of z1 minus z2 is the same as conjugate of z1 minus the conjugate of z2. Alright, then the right hand side, remember to square it as well. So this part, we really get this expression over here. Okay, let's do a cross multiply. So you have a square over z1 minus z2 will be equals to k square conjugate of z1 minus the conjugate of z2. Now similarly, b square can be written as b squared over z2 minus z1 will be equals to k, or sorry, this will be 2 and 3, z2 over z3, 3. So this will be conjugate of z2 minus the conjugate of z3. Now likewise for c squared, you can write it as c squared over z3 minus z1 will be equals to k conjugate of z3 minus the conjugate of z1. Now let's add all these three together. Okay, maybe I call this 1, and I call this 2, and I call this 3. So 1 plus 2 plus 3. Alright, now the left hand side I will have this expression over here. So let's see what does the right hand side comes out to be. Okay, will be equals to k squared conjugate z1 minus k squared conjugate z2 plus, here should have a square, here should have a square, sorry, here must have a square, okay, because I'm squaring both sides, so will be k square conjugate z2 minus k square conjugate z3 plus k square conjugate z3 minus k square conjugate z1. Okay, so you look at this term and this term can cancel away. Okay, these two terms can cancel away, and you are left with these two terms which also can be cancelled away. So your answer is 0. We have proven the required equation. I hope you have learned something from the video earlier. In the next video, we will be solving this particular question. I will put the URL link right below in the description. I hope to see you again. Thank you.
Like a bird on a tree,